All right, students, here we go. We're going to talk about simplifying polynomials by division, or more specifically today, we're going to be talking about dividing monomials. We're going to need two properties to help us through this, plus some knowledge of simplifying fractions with whole numbers. So we're going to be looking at quotient of powers property, which will tell us that a to the m power, any number a, any number m, being divided by a to the n power, or any number a, again, has to be the same base, we can simplify by saying a to the m minus n. So to boil that down, we're going to, if we had 2 to the 5th divided by 2 to the 3rd, shortcut, we could say, instead of solving it all the way out, we could say 2 to the 5 minus 3, or 2 to the 2nd. Another way to think about this is to say we would have 5 2's being multiplied on the top of the fraction and 3 on the bottom. So if we thought about 5 on top, 3 on bottom, that would give us 3 of them canceling out and leaving 2 2's left over, so 2 to the 2nd power. We also have the negative exponent property that we need to be aware of. If in fact a number is subtracted from our quotient of powers property and the result is negative, we use the reciprocal, or that term would go to the bottom of the fraction. A lot of these you can kind of justify by saying there'd be more on bottom, so it would just stay on bottom, but this is the mathematics behind it. So if we had 3 to the negative 2, we would actually have 1 over 3 to the positive 2nd power. So let's take a look at a couple of these. Again, dividing monomials. First things first, we're going to kind of line this up and look at our negative 12 and 4. We can simplify negative 12 and 4 by either dividing them both by 4 or saying that negative 12 divided by 4 is negative 3. Once we've found our whole number simplification, we can move on to the variables. This says x to the 4th being divided by x to the 1st. These are in need of some simplification. So if I read a little 1 in there just to hold the place because that's understood, we can use our quotient of powers property and say x to the 4 minus 1. Well, 4 minus 1 is 3, so x to the 3rd. Moving on to the y's, we have y to the 3rd and y to the 2nd being divided. And again, quotient of powers property says y to the 3rd, y to the 2nd will be y to the 3 minus 2, or just 1. Since it's 1, I'm not going to write the 1 there, it's understood. And that would be simplified version. Real quick, I want to take a look at a couple more of these, just some situations. By the way, keep in mind, negative divided by a positive there is a negative number. Let's get that out of the way. Moving along to, we have 6x to the 3rd, y to the 7th, z to the 2nd, all being divided by 30x, y to the 10th, z to the 2nd. So in looking at our simplification of the whole numbers, first of all, I see a 6 and a 30. I'm going to kind of treat this like it's a 6 over 30 fraction, and I could divide both of these by 6, giving me 1 and 5. Since the 1 is understood, we wouldn't have to necessarily write that. So let's just say here's our new fraction, and we have 5 on the bottom. The 1 would go right here, but since it's understood, we don't need to write it. Moving on to our x's, again, we have to match up with the variable. Here's an understood 1 right there, x to the 3rd, x to the 1st, 3 minus 1 is 2, so we have x to the 2nd. Here's where we might need the negative exponent property. We have 7 minus 10. Now, y to the 7 minus 10 actually equals negative 3, or y to the negative 3rd, which that negative then means it goes back to the bottom of the fraction, or the reciprocal, so becomes positive y to the 3rd on the bottom of the fraction. You could also think about, I have 7 on top, 10 of them on bottom, 7 would cancel out, leaving still 3 on the bottom, or the denominator. Z to the 2nd, z to the 2nd. If I go z to the 2nd minus 2 or 2 minus 2, that'd be 0, and that's another, anything to the 0 power or z to the 0 power actually just equals 1. It cancels out. So these z's would in fact cancel out. And this is what's left. We'll write in a little bit better format if I say x squared over 5y to the third. That's going to be our simplified answer. Let's move on to the last one here. One more type of problem that you might see. Notice negative, negative. Okay, two negatives are going to make a positive in division, so these would actually cancel out. So let's go ahead and do that right there. 24 divided by 8, or simplify, think about it as a fraction. 24 divides by 8 to get 3 and 1, or just 3 on top of the fraction. Let me put that in there. There we go. We have n to the second and n to the fourth. We need to reason that 2 minus 4 would be negative 2, which then sends it to the bottom, or n to the positive 2 on the denominator. M to the fifth, m to the first, 5 minus 1 is 4, so m to the fourth. We'll just say 3m to the fourth divided by n to the second power. That's going to be dividing monomials, or simplifying using division in monomials. A couple properties to think about again: the quotient of powers property, the negative exponent property, and then again right here, this one came up, the 0 power property. Email me if you have any questions, or private comment on Google Classroom. Thanks for watching.